Hydrogen is the most recent and, I'd say, one of the most promising in a long list of alternatives to petroleum. Some of the possibilities include batteries, ethanol, natural gas, and, well, you name it. But hydrogen fuel cells have a couple advantages over some of the other options. First of all, they're really quiet and they don't pollute the atmosphere. Besides that, hydrogen's the most abundant element in the universe, and it can be produced from a number of sources, including ammonia or even water. So it's renewable, and there's an almost unlimited supply. Okay, now, fuel cells represent a radical departure from the conventional internal combustion engine and even a fairly fundamental change from electric battery power. Like batteries, fuel cells run on electric motors. However, batteries use electricity from an external source and store it for use in the battery, while the fuel cells create their own electricity through a chemical process that uses hydrogen and oxygen from the air. Are you with me? Look, by producing energy in a chemical reaction rather than through combustion, a fuel cell can convert, say, 40 to 60% of the energy from the hydrogen into electricity. And when this ratio is compared with that of a combustion engine that runs at about half the efficiency of a fuel cell, well, it's obvious that fuel cell technology has the potential to revolutionize the energy industry. So, fuel cells have the potential to generate power for almost any kind of machinery or equipment that fossil fuels run. But the most important, let's say, the goal of fuel cell technology, is the introduction of fuel cell powered vehicles. Internationally, the competition is fierce to commercialize fuel cell cars. I guess all of the leading automobile manufacturers worldwide have concept cars that use fuel cells, and some of them can reach speeds of as high as 90 miles per hour. Even more impressive is the per tank storage capacity. Can you believe this? Some of those cars can run for 220 miles between refills.
Nej,
But
hon är inte kär i
many
honom.
of those cars were designed decades ago. So, what's the holdup? Well, the problem in introducing fuel cell technology is really twofold. In the first place, industries will have to invest millions, maybe even billions of dollars to refine the technology. And here's the real cost: the infrastructure to support the fueling of the cars. And by infrastructure, I mean basic facilities and services like hydrogen stations to refuel cars and mechanics who know how to repair them. I think you get the picture. And then, consumers will have to accept and use the new products powered by fuel cells. So, we're going to need educational programs to inform the public about the safety and convenience of fuel cells if we're going to achieve a successful transition to fuel cell products. But, unfortunately, major funding efforts get interrupted. And here's what I mean. When oil prices are high, then there seems to be more funding and greater interest in basic research and development, and more public awareness of fuel cells. And then the price of oil goes down a little, and the funding dries up, and people just go back to using their fossil fuel products. And this has been going on for more than 30 years. Some government-sponsored initiatives have created incentives for fuel cell-powered vehicles, but probably one of the most successful programs, at least in my opinion, is the STEP program, which is an acronym for the Sustainable Transportation Energy Program. STEP is a demonstration project sponsored by the government of Western Australia. Now, in this project, gasoline-driven buses have been replaced with fuel cell buses on regular transportation routes. I think that British Petroleum is the supplier of the hydrogen fuel, which is produced at an oil refinery in Kwinana, south of Perth. So we need to watch this carefully. Another collaborative research effort is being undertaken by the European Union and the United States. Scientists and engineers are trying to develop a fuel cell that's effectively engineered and attractive to the commercial market. Now, under an agreement signed in about 2000, if memory serves, it was 2003, but anyway, the joint projects include the writing of codes and standards, the design of fueling infrastructures, the refinement of fuel cell models, and the demonstration of fuel cell vehicles. In Europe, the private sector will combine efforts with government agencies in the public sector to to create a long-term plan for the introduction of fuel cells throughout the EU. And the World Bank is providing funding to promote the development and manufacture of fuel cell buses for public transportation in China, Egypt, Mexico, and India. And we're starting to see some really interesting projects in these areas. So, clearly, fuel cell technology is an international effort. Okay, at the present time, Japan leads the way in addressing the issues of modifying the infrastructure. Several fueling stations that dispense hydrogen by the cubic meter are already in place, with plans for more. But even when a nationwide